So with question 1, it says factorize x squared minus 6x. So I'm looking for either a number or a letter or both that goes into both. Now obviously there's no number in front of the x squared, so that means there isn't going to be a number outside the bracket. But because x is in both, I can take x out as a factor. So then I'm looking at how many x's times to make x squared, so that would be x times x by there. And then to make minus 6x, it would be x times minus 6 there. So effectively what I'm doing when I take x out as a factor, I divide each of these by x. Okay? For the next bit, we looked at one of these earlier today. We always look for the lowest amount of x out of these two. And the way that Sir's been doing it is that you balance the equation. So you look at saying, right, get rid of that 3x. So I take away 3x from there. But whatever I do to one side, I do to the other side. 7x take away 3x gives me 4x there. That plus 13 doesn't get affected by the x's, so that plus 13 is still there. And that equals 5, or positive 5, but it's fine to get rid of that plus sign now because it's all there on its own. Then I get rid of the plus 13, so I take away 13, but from each side. And then 5 take away 13, pop it into your calculator, comes to minus 8. So 4x equals minus 8, and then to get rid of the 4, you divide 4 on both sides, and that will give you x equals minus 2. The question says, using a ruler and a pair of compasses, construct an accurate diagram of the logo. You must show all your construction lines. Okay? So what I did to make my 60 degrees, so I measured it, but that is not good enough because it says here in the question, using a ruler and a pair of compasses. It doesn't say I'm allowed to use a protractor. Okay? So what I should do to make a 60 degrees angle is I should open my compass to 8 centimeters there, and I should draw an arc like that coming in that way, and I should have drawn an arc coming in that way, and where those two cross, I would have joined up to 8 centimeters, which would have been the same size as that line there. Okay? That starts to make an equilateral triangle to there, and we found out yesterday that an equilateral triangle, all the angles are 60, so that would make 60 there. You shouldn't be using your protractor to measure that. Okay? Once you've got the end of that line there and the end of that line there, because in the drawing it says these are both 5.5 centimeters, you should open your compass to 5.5 centimeters, and you should pivot your compass on the end here and draw an arc of 5.5 centimeters in there. And then you should move the point to this point here, and you should draw another arc of 5.5 centimeters. And where those two meet, you join them up to each end of the line there.
So the question says, who is in the lead in the first length of the race? And use the graph to explain your answer. So because it's telling us to explain our answer, we've got to do that, okay? It says to explain it. You've got to explain it. You can't just say Michael. Michael, you wouldn't get your mark for it, okay? So on this one, all you've got to say, why would you pick Michael? Is because he gets to 50 meters there quicker than Jordan does, okay? And like Meg said earlier, you are just pretty much repeating the question, but it's just explaining it a little bit, just showing some sort of explanation, okay? For the next bits, we have to do what we did a couple of times this morning. Okay, this bit here, where you've got to read from the scale. So we're going from 0 to 20, and there's 10 little tiny dots, tiny squares in between it. So you're dividing that 20 into 10 squares. So 20 divided by 10 is 2. So each little square is worth 2 seconds. Okay, that'll help us later on. And going up the side, that's not really an issue, is it? Because there's 10 squares and 10 numbers. Okay, so it's as it is. All right, so the next question says, what was Michael's average speed for the first length of the race? So be careful you pick the right one. We've got Michael's, which is going to be this one here. Okay, so we're going to use this one here. Okay. So that bit here is going to be Michael's first length of his race. Okay. So what we do, first of all, we write down speed equals distance over time. We read from the graph. If you look at the graph here, he reaches there. 50 meters is our distance. And he does that, look at the bottom, in 40 seconds. It doesn't tell us to do kilometers per hour or miles per hour or anything else. All it says is whatever you pick, you give the units. So we can do it exactly as is on the graph. We do 50 metres, which is our distance, divided by 40 seconds, which is our time. But if we do that, the answer is going to be 12.5 on a calculator, but you put metre slash s.
It's 1.25.
All right, checking that. Sorry, this one, that should be 1.25. Okay, not 12.5. Okay, it's been a long week. We've done lots of papers for you. Okay, so it should be 1.25 meters per second. So change, if you got that, put 1.25 meters per second. Okay. For what length of time were Michael and Jordan swimming in opposite directions? Okay, give you a second to have a look at that. Okay, so you look at your graph. They're swimming in opposite directions when here, by here, he's going that way, and he's going that way. Okay, so if one of them is going downhill and the other one's going uphill, okay, that's when they're in opposite directions. Because remember, the direction of the gradient of the slope is the direction they're going. So if one's going downhill, they're going away from that distance. If they're going uphill, they're going towards that distance. So between here and here, because you think about it, as he's swimming that way, he reaches that bank, then he goes back, but at the same time, he's still going that direction, isn't he? Okay, so as he turns back by here, he's still swimming in that direction, till he gets to that point, at which point here, they're both swimming in the same direction from then onwards. Okay? So we're looking for the distance between here and there. All right? So you read on the graph. So that's between 40 seconds and there. That point is 40. So each one is worth 2 seconds. So 1, 2, 4, 6, 8. So for 8 seconds distance. Okay? So for 8 seconds, they were swimming in different directions.
Okay, make sure you listen, please. For question number 4, you should be looking at splitting this shape up into shapes that you recognise, which for me would be a square, although it's not necessarily a square. If you look here, it's 7 and it's 6.5, so that's actually a rectangle, although it does look very similar to a square. And then a triangle. But you'll notice here that red line here for the triangle I've got there, that 3 metres, I had to work that out by doing 9.5, take away 6.5. Okay, so that's how I worked that one out. The formula that you should know for your triangle is base times height divided by 2, as we looked at in a recent lesson. And for a rectangle, it's just base times height, no divided by 2. So for area A, this one up here, it's going to be 3 times 7, all divided by 2, and that comes to 10.5. You can leave that as 21 over 2 if you want, but I'd recommend you put that into decimals. And for the area of the rectangle, it would be 7 times 6.5, which is 45.5. Therefore, the total area is 56 metres squared. Part B says, a tin of paint covers an area of 15 metres squared. How many tins of paint does Anil need to buy in order to paint the side of his house? I've shown 2 ways. I've shown like what I think is the most obvious way, which is just by counting up in tins. So 1 tin would do 50 metres squared, 2 tins would do 30 metres squared, 3 tins 45. Hence, it must be 4 tins, because that does the area that I need, the 56 up there. You could have done 56 divided by 15, which tells you need 3 and a bit tins. Now, I know this is 7, you'd say, oh, round that up to 4, but even if that was 3.002, you'd still need 3 and a bit of a tin. So you'd still need to buy 4 tins no matter what. So I prefer to do it this way, as I think is a little bit more logical. But if the numbers are too big, then obviously you can't do it this way. Okay? Question number 5. Make sure you're getting things written down if you've got nothing down. You need to know that formula. As soon as you see a circle, it's a good idea to get down the formula for area. You could also get down the formula for circumference, but be careful not to confuse yourself between the two. Okay? Pi r squared, the one with squared in it, is the area one. Okay? You'll see here that the question actually tells you the diameter of the small one and the diameter of the large one. That information is actually irrelevant because we need to know what the radius is, and the radius is always half of the diameter. So if they tell you the diameter is 7, the radius must be 3.5 for the small pizza, and the radius must be 6 inches for the large pizza. Okay? It says, calculate the area of the top of the large pizza. So the top of the large pizza would be pi r squared, this formula from up here, and then that would be pi times 6 squared. And be careful, 6 squared isn't 6 times 2, it means 6 times by itself. Make sure you put it into your calculator looking like that. Because the common misconception is people say, oh yeah, just times it by 2 and it's not squared, doesn't mean that. And that gives me 113.1 inches squared, although I should have said in brackets to 1 dp. The second bit says, by considering the area of the top of each pizza, decide whether it is better value for money. So what I did was I looked at the area of small pizza that I got, so pi times its radius squared, that came out as being 38.5 inches squared. I then tried to work this out by value by saying £4 for the small pizza, I'm told here it costs £4, gets me 38.5 inches squared of pizza. Okay? Whereas for the large pizza that costs £10, that gets me 113.1 inches squared of pizza. So to compare those to see which one is the better value, I found out what the cost was by this one. I divided by 4. So I divided the area by 4. So that told me that for £1 I was getting 9.6 inches squared of pizza. Whereas for this one, I just divided by 10. So I divided this by 10, and I found that when I was buying the large pizza, I was actually getting more pizza for my money. I was getting 11.31 inches of pizza. So all I've done is summarise by saying the large is better, as for £1 you get more pizza for your money.
All right, so ratio question. So like this morning, we're going to use method of finding out, first of all, what the total ratio was. Okay? So you do that by you add up how many parts there were in total in this ratio. So the ratio is 72 to 1. So composite steel, chromium, and nickel. Doesn't matter, but you add them up and you get a total of 10 parts. So there's 10 parts altogether. We're trying to make 500 kilograms. We're trying to find out how many kilograms is each part worth, okay? So there's 500 kilograms in total. Each part has got 50 kilograms in it. So now what you do is chromium steel is 7 parts, so 7 lots of 50. Sorry, composite steel, 7 lots of 50. Chromium is 2 lots of 50. And nickel is 1 lot of 50. So just as a check, you don't need to do this bit here. What we're doing now is just adding it up to make sure we haven't missed any. Then you use the table at the top, and it says a composite steel is 50 pence. We're getting 350 kilograms. So we do 50 pence times 350 kilograms. If you're using 50 pence, be careful. Keep it in pounds, okay? So 50 pence, put 0.50 times 350, gets you 175. Chromium is 100 parts, £1.90 per kilogram, so £190. And the nickel is £12.70 per kilogram. We need 50 kilograms, so in total there, for nickel, we have 635. To find how much money it is in total then, you add 175, 190, and 625. Okay, giving us a total of £1,000. Okay? And again, remember what we said before? QWC, just write down what you're doing. Just say, I'm adding a part together to find one part. Write down a bit of annotation just so you're aware, or you can show the person, I know what I'm doing and I can explain it to someone. Okay?
So, trial improvement will always be worth 4 marks, but a couple of things to notice before we start this question. It will tell you somewhere what the formula is, 99 times out of 100, and it will tell you 2 numbers to start with. Okay? Now, what you should do as part of your method for this is you should create a table. I'd always recommend that your table, that the X column is really narrow, this one here is really narrow, and this one here in the middle is really, really big. Okay? So you have X, you have whatever that formula is there, comes in here, exactly the same thing. And then here you have a comment. Okay? So first of all, I tried the numbers that I'm given in the question. So the numbers I was given in the question were 4 and 5. The reason why I put in 4 and 5 is because I get a mark for just substituting those two numbers in. So I've done exactly the same as we did earlier today. X has changed to open brackets, and I've just put in 4 here because I said 4, so 4 went in there and there. When I put that in, my answer came to 76, so I'm supposed to get 90. So that is too small or too low. So that's all I've written here, TS for too small. When I put in 5, I found that I got 140. I'm supposed to get 90, so that is too big. TB or TH for too high. Because I've gone in between 4.5, I found that 4 is too small and 5 is too big. I've tried in the middle of 4 and 5. You don't have to try in the middle, but I'd recommend going straight to 4.5. So all I've done now is just change my brackets to 4.5, and in your calculator you should be using the replay button to stop you having to write out the same formula over and over again. That answer comes to 104.625. Bear in mind I'm supposed to be getting 90. That means it is too big still. Now the next logical one to go to is the counting numbers. If you don't do the counting numbers, you are liable to miss the rest of the marks in this question because it wants to see you go too small, then too big again like here, but they have to be in consecutive numbers. So for the next one that I chose 4.4. So go down a counting number if it was too high. If it had been too low for this answer, I would have gone 4.6. When I put in 4.4, I've subbed that into my formula and I got 98, which is still too big. So I'm now going to 4.3. When I sub in 4.3, I still get an answer bigger than 90, so it's still too big, so I need to make X smaller. And I try 4.2. And finally, I've got a number underneath 90. So I now get my next mark for having this go too big and then too small, just like I got my first mark here, 1, 2 marks so far. But they have to be consecutive numbers. It has to be one after the other. It has to go 3, then 2. If I'd accidentally missed out the 4.3, then gone in between 4.4 and 4.2, I wouldn't have got any more marks in this question. So my solution must be between 4.3 and 4.2. Although it says in the question here, go to 1 decimal place, you always go to 1 decimal place further. So the number that is in between these two is 4.25. So into that formula has gone 4.25. And then for my solution, I got 89.51, which is too small. Now for some people, that won't actually make much sense. So I'm going to show you what that's telling us. If I looked at a number line where I had 4.2 one side and 4.3 the other side. When I tried 4.2, the solution was too small, so I said try a bigger number. I tried 4.3 and that was too big, so I said try a smaller number. By going bang in the middle of those two values and finding this value is too small, it tells me to try a bigger number, hence the solution must be somewhere between these two values. That means it is closer to 4.3. Without doing this line here, as soon as you go to 2 decimal places, you get an accuracy mark for going 1 further than the question said. Only then can I get this mark. But if I hadn't have done this mark here, I can't get that mark even if I did guess correctly.
Stop doing it that way. Thing. Across and 2 up, 1358, 14513, 155 across 22 up, and 16510. So putting that into the table below. So all you're doing is plotting these points here. Again, like you see a lot of in these questions, we're having to work out what the scale is. Okay? So between 0 and 4, so 4 is divided into 10 pieces. So each one is worth 0.4, which isn't really that nice to think of. Because we're only dealing with whole numbers, though, because each of our frequencies is just whole numbers, what I would do is I just work out between 0 and 4, we're going to have 2. Between 4 and 8 is going to be 6. Then 10, 14, 18, and 22. Okay? So once you've got that, it makes it easier to plot all the points then. Because when you're doing the only one that's odd is 13. So for this one, we go 1, 4, 5 across, and we go between 12 and 14, would be 13. Okay? For the next question, they've asked us to calculate the mean height of the children. So what you've got there doesn't really help you that much, because what they've done is they've used the table, we've used the table beforehand. So that mean, remember, is your total divided by how many? Okay, for this question, the area of each one of these bars is the frequency. So in a histogram, to work out the frequency is the class width times frequency density. But I just like to remember that the area in a histogram is the frequency. So to find the area of each one of these rectangles, you're doing between 10 and 20 is 10 across, and we're going up 0.5. So 10 times 0.5 gives us 5. Then for this bit here, 5 across times 0.8, okay, is 4. Between here, we're going 10 across and up to 1. Sorry, 5 across, sorry, up 1, so 5 times 1 is 5. Here we're going 5 across and up to 1.5, 6, 7, 8, 1.8, which is 14. Here, doing 5 across and going to 1.6. Sorry, 2.8, sorry. 5 across and up to 1.6. 5 times 1.6 is 8. And finally, 20 across, going up 0.6, sorry, 0.3. 20 times 0.3 is 6. So you work out the areas of each one of these, being careful with the decimals. You then add them up. If we've got 42, our median is our middle. Median is the middle one. So we're trying to find out where the 21st, the halfway person, would be. So you half 42, gets to 21. We're trying to find where the 21st one would be. Okay? So we know adding up each one, there's 5, add 4 is 9, add 5 is 14. So we've got 14 now. We want to see where the 21st one's going to be. Because in this one here, we've got 14, we know to add up to get to 21, we need another 7 add on to 14. So it's going to be the middle point of here. Okay? So the middle point here is going to be our median. So reading down from here, reading on the graph, you get 32.5. This bit, doing this, is not the important thing I want us to be confident doing. What I want you to be confident doing is working out the frequency from histograms, because the area of each block is the frequency. And what I'd also like you to be confident doing is drawing a histogram